This is a quiz about GaussianRandomProjection, a dimensionality reduction technique in the scikit-learn library. I'll be testing your understanding of its parameters and how they affect the outcome. Get ready. This is the core problem. We're given a dataset with 1,000 features and want to reduce it to 500 using GaussianRandomProjection. The goal is to mostly keep the distances between data points the same after the reduction. I need to evaluate 4 statements about this process to determine if they're true or false. Let's dive in. This statement checks if setting the _random_state parameter to 42 makes the results the same every time. I should know that _random_state is used for reproducibility in algorithms involving randomness. Setting it to a fixed value, like 42, ensures consistent results because it seeds the random number generator. Think of it like using the same recipe every time you bake a cake. You get the same result. This statement asks what happens when I increase the target number of features, n_components. Increasing the number of components means I'm retaining more information from the original dataset. This naturally leads to a smaller difference between the original and reduced datasets, lower reconstruction error. It's like keeping more of the original cake ingredients. The resulting cake will be more similar to the original recipe. This statement tests my understanding of how well GaussianRandomProjection preserves distances. It's crucial to remember that GaussianRandomProjection is an asterisk approximate method. It doesn't guarantee perfect preservation of distances. That's not how it works. It aims for asterisk approximate preservation. This statement focuses on the _eps parameter. I need to know that _eps controls the accuracy of the projection, not the dimensionality directly. A smaller _eps means I want higher accuracy, requiring more components, higher dimensionality, not less. It is n_components that sets the dimensionality. This simply indicates that the section presents the options or choices available. This indicates that this part presents the actual question for you to answer. I'm going to explain the parameters in scikit-learn's GaussianRandomProjection that we need to understand to answer the quiz questions. Let's start. This parameter specifies the number of dimensions you want to reduce your data to. For example, if you start with 1,000 features and set, you're aiming to reduce your data to 500 features. It's like squeezing a lot of information into a smaller space. This parameter controls the accuracy of the dimensionality reduction. A smaller EPS value means you want to preserve distances between data points more precisely, but it might require more dimensions, a higher NCOMPONENTS value. Think of it as a trade-off between accuracy and the degree of dimensionality reduction. More accurate, likely higher dimensionality. This is for reproducibility. Setting it to a specific number, like 42, ensures that you get the same results each time you run your code. It's like setting a seed for the random number generator, so the random process isn't truly random, but rather predictable. This parameter in scikit-learn's GaussianRandomProjection controls the number of features you want after dimensionality reduction. Think of it as your target size. A larger number means you keep more of the original features, potentially leading to better accuracy but also more computation. In GaussianRandomProjection, EPS controls the level of accuracy you want in preserving distances. A smaller EPS means you want to preserve distances more accurately, but you'll need more components, meaning a higher resulting dimensionality. It's a trade-off between accuracy and dimensionality reduction. This is a seed value for random number generation. Think of it as a starting point for your random process. Setting it to a specific value, like 42, ensures that every time you run the algorithm with the same settings, you get the exact same results. It's great for reproducibility and debugging. It's like having a recipe for your random numbers. This section's focus is understanding the various parameters for Gaussian random projection in the scikit-learn library, their roles and interactions. I'll help you get a good grasp of how they affect the dimensionality reduction process. Let's break it down. This parameter controls the number of features you want after dimensionality reduction. Think of it like deciding how many pieces you want to break your puzzle into. In this case, you want to reduce from 1000 to 500 features, so your n_components would be 500. This parameter in GaussianRandomProjection controls the error tolerance. A smaller "eps" value means you want to keep the distances between your data points more accurately. It's like setting a tolerance for how much error you'll allow when measuring something. The problem states that the default is fine, so you're not changing this. This parameter ensures that every time you run your code with the same "random_state", you will get the same results. It's like setting a specific starting point for a random number generator. I use the analogy of selecting a specific playing card from a deck, ensuring the same randomness each time. It's super useful for debugging and sharing results. This is the desired number of features after applying dimensionality reduction using GaussianRandomProjection. It's the target dimensionality, hence, I set my "n_components" to this value. This is the initial number of features in my dataset before applying dimensionality reduction. It's the starting point for the reduction process. This section's title clearly tells us that we'll be analyzing the parameters used in Gaussian random projection, a dimensionality reduction technique in machine learning. I'll examine how each parameter affects the algorithm's behavior. This is the core question. We'll evaluate several statements about how the Gaussian random projection parameters work in scikit-learn, a popular Python library for machine learning. Setting the "random_state" parameter to a specific number, like 42, ensures that the random number generator used within Gaussian random projection always produces the same sequence of random numbers. This makes the results reproducible, guaranteeing the same output each time you run the code. The "n_components" parameter determines the dimensionality of the reduced data. Increasing it means you're keeping more information from the original data. More dimensions result in less information loss. Consequently, reconstruction error, the difference between original and projected data, decreases. This statement is incorrect. Gaussian random projection uses random projections, which are approximate. It aims to preserve distances approximately *, not perfectly. It's not an exact transformation. This statement is also incorrect. The "eps" parameter controls the accuracy of the projection. A smaller "eps" means you want a more accurate projection, which typically requires a higher asterisk, not lower, dimensionality to achieve. This tells us we're dealing with a high-dimensional dataset, having 1000 features initially. Gaussian random projection is useful for reducing the number of features in such scenarios. I'm analyzing the parameters of scikit-learn's GaussianRandomProjection, a tool used for dimensionality reduction. I'll focus on how its parameters affect the process. This is a multiple-choice question. We need to evaluate 4 statements about GaussianRandomProjection and determine which ones are correct based on my understanding of its parameters. I found that setting the "random_state" parameter to a specific value, like 42, makes the results reproducible. It's like setting a seed for the random number generator. The same sequence of random numbers is used, leading to identical outcomes every time you run the code. Therefore, this statement is true. The "n_components" parameter determines the dimensionality after reduction. Increasing it means you retain more information from the original dataset. Think of it as keeping more pieces of a puzzle. Less information is lost, resulting in a lower reconstruction error, the difference between the original and reduced data. Thus, this is true. This statement is incorrect. Remember, GaussianRandomProjection uses random projections, which are approximate methods. They don't guarantee perfect preservation of distances, they aim for an approximation. So, this statement is false. The "eps" parameter controls the accuracy of the projection. A smaller "eps" demands a higher dimensionality to maintain accuracy. It's the other way around. Eps doesn't directly control the reduction. The "n_ components" parameter determines the target dimensionality. This statement is false. We are working with a dataset that initially has 1,000 features. The goal is to reduce this number using GaussianRandomProjection while preserving pairwise distances as much as possible.